Ladies and gents, welcome back to another Engineers podcast. Today I'm joined by Ashley Grealish, who's the VP of Engineering at an organisation called ev.energy. We've really recently had another business on the podcast who've spoken about a similar space. So, we're all for green, sustainability, ev.energy, and we're going to explore this a little bit more and some of what they're building. But they're a charging app helping customers calculate the simplest, cheapest, and greenest way to do EV. Ashley, thanks for coming to join us.
Thank you. Thank you, Ella.
Pleasure. We always start by learning a little bit more about the guest and some of their background. So, do you want to give us an intro into Ashley and help us understand a little bit more about the elevator pitch, if you like, for EV Energy?
Yeah, of course. Yeah, I'm Ashley, as you mentioned. I'm the VP of Engineering here at EV Energy. I'll start with my background, perhaps. I been in startups for a little while now. I've been always focused on sustainability and specifically, I guess, going back a few years, I studied electronic engineering and I've always been interested in that.
Mm.
Um, Intersection between hardware and software. And the startups that I've worked for have been in sustainability, but also in that kind of space. So thinking a lot about energy, previously off grid solar energy for a long time. And now energy in the terms of electric vehicles and how we can use them to, to drive change in the energy system. So EV energy, very quick uh, intro to what we do. As you said, Elliot, we manage the charging of electric vehicles. So we change when and how they charge to use energy that is greener, so lower carbon emissions, and cheaper, so lower cost to actually charge your car. We can go into that a lot more detail throughout the call, but yeah, that's the kind of headline. What we do.
Yeah, I'd love to go into that a little bit more and just understanding, I think, the business makeup. But you're absolutely right. I think what I've also found fascinating, and we've spoken now to a couple of companies, excuse me, in the sustainability space, that intersection between the hardware and the software piece, my understanding throws up a couple of complexities. So it would be good to understand what are some challenges from your side that you see around the hardware and software intersection.
Yeah, of course. I guess I can give you a little more flavor on EV energy first to
Yeah.
kind of set the scene and then dig into that question. So, as I said, we manage the charging of electric vehicles. Um, Let me tell you a bit about how it works. So, an example kind of run through of how it might work. If you're a driver of an electric vehicle, you can go to the App Store, you can download our app, and then within the app, you're going to connect your car or your charger into our platform. So we connect those chargers in different ways, which is really your question that we'll go into. But then we manage that charging, as I said. So we need to know when is greener, when is cheaper, and so we integrate a lot with the energy system, the energy market, maybe your utility provider, the energy grid operator, those sorts of people, and understand from them when is greener, when is cheaper, and then we manage your car to suit those times. So connecting to cars, connecting to chargers, we do a lot of that. What are the challenges? I think EV energy has focused a lot on market coverage. So when you go to the App Store, when you download the app, we want you to be able to onboard. We don't want to say, sorry, you don't have a compatible car, sorry, you don't have a charger for this. So we've really focused on getting wide market coverage. That means I think we're at more than 20 brands of electric vehicles and about the same in electric vehicle chargers that we're compatible with. Um, and all of those, as you can imagine, are slightly different. So every car brand has a slightly different solution. every charger brand has a slightly different approach to the problem of connectivity. So when we think about what are the challenges, let's split it up a little bit. Let's talk about chargers first. Um, Chargers. When I talk about chargers, I think just so we're in the right space, we're talking more residential charging. So the types of chargers you'll see in a driveway or in a shared car park, something like that. Not the big things you see at motorway service stations, like that. So these chargers, they're at people's homes. They're connecting over maybe the home Wi-Fi or perhaps a mobile network. These are pretty good, but the charger is often outside, quite far away from say the home router or something like that. Um, they're typically internally running kind of lower power or lower spec kind of compute inside of it. So getting those to connect reliably to our network and do so in a secure way with encryption, authentication, all of this sort of thing. This can be a challenge, and this is something we're really, really strict on. We want them to connect reliably, but we want them to connect securely as well. So yeah, we spend a lot of time with our partners making sure we can get that secure connection into our platform, and more importantly, keep it connected to our platform over time. The challenges on the vehicle side are probably a little bit different. So um, EVs, like most kind of new cars, will come with a telematics solution or internet connectivity built in. So you can use the vehicle manufacturer app. You can check um, perhaps how much battery level you have, where the car is, that sort of thing. Maybe start the heating remotely. Um, that internet connectivity that's built into the car, that's what we use. So we're kind of leveraging that inbuilt hardware into the car to connect to the vehicle. That's typically quite good. We can connect quite well via the manufacturer's platform. But the challenges are that cars move about. They sometimes go underground. They sometimes go in low signal areas. So we have to manage that, and we have to think about how we message the correct thing to the user. Um, we don't want to say we've lost connection to your car when in fact it's just parked underground for a short period, like that. So yeah, we have to manage the fact that cars can move, which is, I guess, fairly obvious.
Yeah. Excuse the irony, but there are a lot of moving parts in
Yeah,
this. And I think offline, we want to particularly focus on the data ingestion of the platform. And you specifically wanted to focus on the collection and cleanliness of the data across millions of EVs and cars that you're actually sourcing this info from. So, do you want to just break down that problem set for us and talk to the audience around how you do that?
yeah, of course. Yeah, I guess let's again split it into, well, maybe before I split it down into the two, I think one of our key strategies, and this is perhaps an interesting kind of lesson from our business, is that we try to connect to, we call it both ends of the cable. But what that means is to the car and to the charger. And we do that for a few different reasons. One is that chargers can give slightly different data to cars, and cars give slightly different data to chargers. And together we can get a really good picture of what's going on. But almost as importantly, there's redundancy there. So I talked about some of the challenges of connectivity, maybe things going offline at times. If we integrate with both ends of the cable, we have some resiliency, some redundancy in the system. The But yeah, then drilling back down into how we connect chargers. Um, I see three kind of archetypes of how to integrate a charger or a similar bit of hardware. So the first is that the charger will directly connect to our backend. So it will, point at our server, it will send data, it will accept commands back. And the protocol that it uses between the charger and the backend is some proprietary um, thing for that manufacturer. This is probably the most challenging one. This is by its nature means it's unique charger brand, and we don't um, try not to do that. The second way of doing it is a cloud to cloud, we call it integration, where you have a charger brand, they have their own software service, and their charger is communicating with their cloud system. And then we sit alongside that and we communicate with their cloud system via APIs. That's nice in some ways. That means the responsibility of keeping things connected is on the manufacturer. We get a nice clean API. And then, yeah, the third way is similar to the first, except there is a protocol within the charging ecosystem called OCPP, the Open Charge Point Protocol, which is a WebSockets based JSON standard, so that the charger opens a WebSocket directly to our backend, and we can send messages backwards and forwards. This is quite nice because it's standard. We can reuse it across lots of different chargers. But the complexity comes where not everything is quite as standard as it should be. Some people have only implemented part of the spec or interpreted things in different ways. And we have to manage that complexity. Um, the the other challenge is the WebSockets part of it. So every charger is communicating with us and opening WebSocket. And like you said, we're not quite at millions of chargers yet, but that's where we want to go. As we get to millions of chargers, there's definitely going to be challenges to face. And how do we keep open
Yeah.
millions of WebSocket to chargers?
And the space is evolving so much, and you talk about uh, 20 manufacturers. That number's going to increase with
Yep.
government commitments that we often see in the press. So there will be further manufacturers to integrate. And I think I quite like your third point around the reusability of some of that to be able to integrate with other manufacturers. I can imagine, and this is me doing some guesswork here,
Mm.
but I can imagine that zero to one manufacturer, finding your first manufacturer and exploring, or even on each point, exploring some of the challenges and what could go wrong. Even as an example, the cloud to cloud solution, I guess the first time that you're doing an integration like that, you're learning a lot more about how you can go faster.
Yeah, I think I mostly agree with that. I guess there's an
Okay.
interesting there's an interesting kind of caveat there in that um, if we talk about vehicles now instead of
Yep.
chargers, some of those vehicle telematics solutions that we've talked about, some brands are much better at building high quality telematics solutions than others. So our first integration was to Tesla vehicles, which um, even when we started 5 years ago, had a really robust telematics solution that allowed us to do everything that we need and to allow us to build a fairly um, robust system around that. And then that's got better and better over time. So um, about a month ago, Tesla released a major overhaul of their telematics solution that makes it even better, even more robust, even more reliable. So that first one, we did learn a lot, but we were also, I guess, a little bit privileged in that we were working with a really high quality
Mhm.
service to start with. And then as we go through more and more brands, we find different issues um, and things like that that we have to do more learning on. So I guess yes and
Okay.
no to that.
Yeah. Okay. Fair point. Fair point. It would be good to go back to my previous question. You're obviously collecting, cleaning the data. Data is, a necessity for businesses nowadays. It would be really good to understand how and what you're using this data for to inform manufacturers, to inform customers about using your platform, or just generally
Yeah.
the collection of data.
Yeah, of course. So I guess the starting point for this is when a driver connects their EV or their charger to the platform. But first thing we're going to do is collect data from that charger, things like is the cable plugged in, what's the state of charge of the battery, those sorts of things, and then recreate a view of the charging session. So we can give a really simple view of you plugged in at 6 p.m., you charged till 10 p.m. Actually, maybe we'll dig into that example a bit more because hopefully not that, but say you did that, and we would then look at, at our integrations with the energy markets to see that charging session from 6 p.m. until 10 p.m. cost you X amount of money and emitted X amount of grams of CO2 for that charging. That's the first thing. So we provide some visibility into what is the impact of your charging in terms of cost and carbon. Um, but the step beyond that, and this is the true value of EV energy, is controlling that. So I said there, maybe you got home at 6 p.m. with your EV, you've plugged in. Typically, it would just charge from then till it's full. So say you've commuted for a few days, not very far, you need to charge maybe 40%. Um, let's say it takes 4 hours to charge 40%, because I said 10 p.m. earlier. So that would charge from 6 p.m. to 10 p.m. 6 p.m. to 10 p.m., especially in the UK, that would be a very expensive energy cost time. Um, for a driver, if you have like a fixed rate tariff, maybe you won't notice that. Maybe the energy supply won't be exposing the fact that that's a more expensive time to charge to you, but it is. And it's in terms of carbon, the dirtiest time to charge because everyone is coming home, cooking, they've got their lights on, heating, that sort of thing. You need to do things like fire up some new gas power plants and things like that. So 6 p.m. to 10 p.m. is bad. So what we do, as well as telling you what the impact of that was, is optionally we can move that charging to when it's better. So um, we look at the data we have, we look at the data from your car, we see you need 4 hours to charge. And instead of charging at 6 p.m., we will delay that until, say, 1 a.m. in the morning when in the North Sea, lots of wind turbines are generating lots of clean energy. And we'll charge from, said 1 a.m., so 4 hours up till 5 a.m. in the morning. You'll wake up, you'll get into your car at 8 a.m. You won't know, or you can look, but you won't really care about when it charged. All you'll know is it's charged fully. It's used the data that we've collected from your car to know when was the greenest. And it will show you, you've saved X pounds, you've saved this much, this many grams of CO2 morning. So yeah, that's what we use the data for. That's the value that the drivers get from it. But there's a third element to this, which is the energy system. So the energy grid. If we look at somewhere like Germany, where there's a lot of home solar, or maybe California, um, there can be too much generation of solar during the day, and if um, if nothing's done, we have to stop installing new solar. That's not good. We want more solar. So we can work with the energy systems. We can use our data to say, we can see there's going to be a very sunny day in 2 days' time. Let's schedule all of the cars to charge then and soak up that excess solar power that's going to be generated. And that kind of allows that energy system to build more solar, build more wind into the grid. And that's very valuable. And those grid operators, those the people kind of managing that, they pay for those services, and we pass some of that back on to the drivers. So we collect your data, we make it lower cost, lower carbon, we integrate it with the energy market, and then we let you share some of that value back through rewards and incentives.
Okay, interesting. I particularly like. I love all the points. Point number three, I didn't know. I think the power in the algorithm at point number two, as in directing the energy to different times of the day, depending on UK as an example, 6 till 10 p.m. is probably our biggest energy usage.
Yeah.
So I love the power in the algorithm in that way, and I can see why it's a massively attractive proposition for manufacturers, customers to really know this information and gain smart insights from that to be able to use it. Going back to your third point,
Mm. Yeah, exactly.
talk to us a little bit about how building across multiple devices, building across multiple countries, it seems now as well,
Yeah.
UK, Germany, you operate in the US. Talk to us about some of those challenges building really good software.
Yeah, it is a challenge. When kind of interviewing candidates for roles, lots of candidates like to ask, what is the biggest challenge you see kind of
Yeah.
technically? And I think there are obvious ones. We've talked about millions of drivers on the platform. They're scalability challenges. But I always see those as solvable. Like people have solved scalability challenges before. I think, like you're touching on there, one of our biggest challenges is managing the complexity that comes with trying to build a solution that works for everyone everywhere. So any driver can download the app and they'll have a unique combination of a car, a charger, and where are they? Are they in California optimizing for solar or in the in the UK? Um, so yeah, we have a lot of integrations, and I think we talked about 20 vehicles, 20 chargers ish, slightly over that. I think when it comes to code, we have to think really carefully about how do we model those systems? How do we model what the kind of um, mandatory features of a charger are? Because we think we know what a charger is. It kind of charges the car. It's quite simple, but they're all kind of implemented in a slightly different way, and what they can do, what they're capable of, changes. So we have to really think carefully about the right levels of abstraction in our code. How do we model a charger? How do we model its capabilities? How do we do all that whilst keeping the interface for the user super simple? They shouldn't have to worry about the intricacies of what the charger can do. So yeah, we spend a lot of time designing good levels of abstraction, good data models for these systems. Um, and inevitably, a new charger or a new car will come along, and that will have to change. We'll have to rethink what we're doing there. So um, yeah, this ecosystem is changing a lot. Things like
Yeah.
this isn't really a new thing, but vehicles being capable of feeding energy back into the grid, that changes our system quite a lot. That's something we want to embrace. If batteries can charge when it's low carbon and export power back to the grid when um, when carbon emissions from the grid are highest, they can use that clean energy, feed that back in. That can help lower the emissions. But that changes our system again, and we have to think about how do we adapt to
Yeah.
these emerging technologies. That's one way it changes how we write software. And I think the second is really thinking really carefully about quality. So we're asking a driver to trust us with managing the charging of their car. If they wake up and their car's not charged, they're not going to use us for very long. Um, so every user has to have a really high quality experience. So the kind of, I don't know, move fast and break things philosophy to building software, perhaps that doesn't apply so much. We think really carefully about quality and maybe some examples, three metrics that we think deeply about. One is accuracy. So when we say that a car charged by, say, 10 kilowatt hours of energy, how close to the truth is that? Um, if we're getting that from a vehicle, that can change that kind of accuracy, or how accurately it reports that number could change based on weather, like batteries get more efficient or less efficient based on the outside temperature. Every car brand is different in terms of how energy efficient it is at transforming energy into the battery. We've got to adapt our system for all of those things. It has to kind of learn what is the efficiency of this unique combination. And we report on that as a metric that we call accuracy. So, how close to the truth are we? Um, we also think about reliability. So when we ask a car to charge, say in the example we said 1 a.m. to 4 a.m., 1 a.m. to 5 a.m., I think, how reliably can we do that? Are we getting that bang on 1 a.m. till 5 a.m., or are we getting that slightly off? That's a metric we track. That's a metric drivers really care about. And then finally, connectivity. How well are we keeping those cars and chargers connected? We talked about that at the start. That's a number we look really carefully at. So we're a very kind of metric focused software team. We're really looking at those metrics, trying to make improvements on those metrics to ensure that when a driver downloads the app, connects their charger, they just get a really seamless experience that charges their car when they wake up. Never undercharged, never anything like that. So yeah, being metric focused, metric driven, data driven, that's super key in field.
I like those three principles, and actually listening to you explain a little bit more about the product itself, it really is a tier one service. Actually, when you think about how critical it is to people's lives, we have to have an accuracy of data. It has to be reliable 100% of the time. Imagine turning up at a charging station and you can't charge it, and the connectivity point kind of ties in with the second point.
Yeah,
But you really do, and it seems that way, have to treat it like a tier one service. It's mission critical. This is transportation, right?
yeah,
We wait and sit here for a period of time. So, and I think it would be really good to understand what that abstraction level looks like when you're actually looking at building a new integration. It'd be great to understand what kind of discussions are actually going around at that point to know what you actually have to think about, or the level of depth of thought that goes into a new integration.
yeah,
That'd be great to cover.
yeah. Of course. I guess let's talk chargers as the example for this one.
Yeah.
So when we get a new charger, we didn't touch on this, but we're a remote company. We have engineers, about 40 or so engineers around the world. Um, but chargers are physical things, and so we actually have one physical office where a couple of the engineers sit. We send the charger there. They're responsible for kind of powering it up, connecting it to the energy system, connecting it to the internet, and then running for a suite of tests. So we have um, call it the ev.energy test tool, but take a charger, we point it at the system, and it will run through every test for issues we've ever seen in the past. So when we've seen a charger not support this way of doing things, maybe we've created a second way of doing things that allows us to still manage charging but with a different technique. So this test tool will run through all of those and tell us this charger supports starting the charging of cars through this specific command, but not this specific command. Um, and there's some mandatory tests that will run through. So if any of those mandatory tests, things like security, if those fail, we'll go back to the manufacturer and we'll say, we need to fix these things to make it secure before it can come onto our platform. But if it's something where we have a few different options of how to achieve that that outcome, then we'll just see which one works, and then we'll program in a config for that type of charger into our system to say, um, when you have to start charge of this charger, send it the remote start transaction command instead of the like change current to 32 amps command. So yeah, we run through a lot of testing. Then we create a configuration for that charger. Then hopefully the firmware on that device stays consistent. But if for some reason some new firmware is added to that charger, some new developments are made, we'll redo the testing again, update the config, and work through work through that. So yeah, there's a lot of I guess prior experience, testing lots of things, learning what are the options, and more we can now just test the charger, understand what it's capable of, deploy it straight to the platform without having to develop new solutions. But still that will come up as chargers um,
Great.
as they grow. Yeah,
Awesome. In the news recently, there was a series round. Great news. You touched there
yeah,
that there are 40 engineers, some of which are in different locations. Talk to us a little bit about the expansion of EV energy and what people can actually expect, whether you're a software engineer, whether you're a customer, what can people expect from the expansion?
yeah. So like I said, we raised the Series B uh, fairly recently. Yeah, we are expanding our coverage across the world, and we started in the UK. We've done a lot with utilities in the UK and in Europe, um, but almost from the start, we've also been operating in the US. But right now in the US, with various things that are going on, we're seeing a lot of energy utilities, energy markets really push for um, managed charging programs, we call it all, using the EVs that are coming into their area. We should say energy utilities in the US are normally kind of geographic, so they'll serve all customers in one area. They want to use the EVs coming into those areas like New York City to help balance the grid, and we partner with them to be able to do that. And we're expanding more and more across the US and partnering with more and more energy utilities. And the more we do that, the more we can get the value of charging at those cheaper times and pass that directly on to the driver through incentives. So participate in an EV energy run program in an energy utility in the US, and you might save money on your bill um, or through other kind of forms of incentives. So yeah, we're growing. We're trying to make it so that um, any driver anywhere can sign up and they can use the program and get as many incentives as possible. And then what does that mean for the engineers on the team? I think it means dealing with that challenge that I mentioned. How do we manage the complexity as we grow? How do we build software that allows us to grow quickly and integrate with lots of things? So we've talked extensively about cars and chargers, but we also need to integrate with um, hundreds of energy utilities across the world, and they all operate in a slightly different way, and we need to solve that problem too. Um, so yeah, people that are excited about kind of dealing with that complexity and building really high quality, simple interfaces for the end user. Um, uh, yeah, that's kind of what to expect. Those kinds of challenges.
Love it. A number of companies have used engineers as a platform to be able to share a little bit about where they're hiring in their teams and specific locations or tech stacks as an example. Would you like to just give a little bit more oversight in regards to how you're looking to grow your team in what areas so that people listening can come and reach out to you or anyone else in the team?
Yeah, of course. So what are we hiring for? Let me run through, I guess. Well, actually, before that, when we hire, as you've probably heard for other podcasts, we're very mission driven. We really want to use this platform to help address climate change. It's a huge kind of existential threat to everyone, and EV Energy is a mission driven company to at its core. So when we're hiring, we really look for people that are excited by and understand and want to get and want to work on that mission. So if you're someone like that, definitely get in touch. But of course, there's certain skills that we're looking for actively that we need to expand the team. So tech stack wise, Python, Django, on AWS, on the back end. We've talked a lot about what that means. A lot of integrations work, a lot of kind of that interaction between hardware and software. That's important. On the front end side with React Native, we have the main ev.energy React Native mobile application, but a couple of others in partnership with energy utilities. So we have a lot of React Native we need to build, and then a couple of web front ends, one for drivers and one for more admins at these organizations that we partner with, and they are in React. So mission driven tech stack, and then where, as I said earlier, we're a fully remote team. We hire in a lot of different places, but right now we are looking a lot at expanding into the US. So it's kind of helpful if we hire people within the US so that they're on the same um, time zone. So uh, East Coast works very nicely. If you're on the East Coast, you're well placed to work with our teams across from the West Coast in California. We have a lot of people in the East Coast, and then we have a number of people in the UK and Europe as well. So the short answer is we hire everywhere, but at the moment we have a particular focus on the East Coast.
Nice. Okay. I think for everyone listening, you've really got a solid business there. I think we've really dived deep into, the three different areas and three different principles as well. Really, that you're solving some of these challenges and the three principles as to how you apply that to the business. Series B backed, obviously going places, and obviously the expansion into the US is no small feat. So the business is going places. Go and talk to Ashley, go and talk to the team, reach out to them. The careers page is below for everyone else to check out. Ashley, I want to say a massive thanks for coming to join us. You're obviously busy at the moment doing the US thing. Uh, so best of luck. Keep doing what you guys and girls are doing. And we'll no doubt get you on a pod again to see where the business has moved. But again, I reiterate, everyone, if you want a business who are solving mission driven problems, but at some serious scale, go and talk to these guys and girls. Ashley, a huge thank you.
Thank you. It's been a pleasure.
My pleasure. For everyone liking, sharing, reposting this to colleagues, friends, please continue to do that. This builds up the platform and allows us to get to this place. So it's massively appreciated. Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Engineers is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Engineers.io. It's no underscore. We've also got a website, which is Enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.